Hello and welcome to MMO Development. So this week what we're going to be doing is we're going to be taking a look at our at getting Unity integrated. I know that we've been spending a whole lot of time writing code in isolation of Unity, and that was on purpose. Obviously I want CGS to be a language that you can use for a variety of different purposes and not have it tied to a particular GUI framework. So today we're going to be taking all the stuff that we've done, which pretty much boils down to what we have here in our environment, our single environment test, and we get to translate all these properties that get properly compiled and parsed and all that fun stuff into a awesome GUI style. Yeah, this is going to be fun. The first thing that we have to do is we have to actually make CGS work with Unity. And what does that entail? Well, fortunately, I've been compiling against .NET 4.5, which isn't ideal because that's not going to work with Unity. And somebody in the questions panel just says, yeah, because someone will eventually replace Unity's horrible GUI system. Yeah, I'm even thinking of writing my own because I'm getting absolutely sick of having to deal with Unity's GUI system and all its horribleness. But originally, CGS was just built to make working with GUI styles easier, and it just evolved into something a lot bigger than that. Anyway, so back to the code. What I have to do is I have to switch all of these guys over to .NET 3.5. .NET 3.5 is the earliest version of the .NET framework that Unity supports, and it's interesting because .NET 3.5, I don't know if you guys ever heard my history lesson about .NET. .NET has a very interesting history because it has a variety of different versions for different things. Like we have the .NET framework, but we also have the CLR and the C# language itself. .NET 3.5 is a framework that includes the CLR version 2 as well as the C# version 3 and some additional libraries that turn it into 3.5. And since Unity works with the CLR version 2 with Mono, that means that is what we're going to have to target. So what I just did was I went ahead and changed the target platform for all three of these projects to .NET 3.5, as ReSharper's already doing down there. We have some errors. So let's do a Control-Shift-B, get a nice little fancy list of errors, and let's fix them one by one. This is going to be super fun. That was sarcasm. The first thing, when you write a project that targets .NET 4 or .NET 4.5, it includes a reference to Microsoft.C#. Microsoft.C# is a .NET 4 library that includes the supporting code for the dynamic feature, which means we're going to have to go ahead and remove that reference from all of our projects because obviously C# 3 does not support the dynamic keyword. Okay, so we build that again. Now what do we get? Blah, 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 blah. Don't care, don't care, don't care. Let's go ahead and start from the top. So I'm going to right-click CGS base, hit build. Let's fix all these errors. I'm not going to worry about these warnings right now. Wait a sec. Yeah, the reason I'm getting these warnings, it's funny. The MS build system it blows up from time to time. It's actually referencing the existing DLLs that were in existence before I changed the settings, and they're not getting overwritten simply because I don't have a new version of my CGS base built yet. Okay, so we're running into an issue. Is null or white space? That was something introduced with .NET 4.5. I'm going to switch it to is null or empty. Now, the difference between is null or white space and is null is empty should be straightforward. Is null or empty handles empty strings, whereas is null or white space will return true if it has just white space characters in it. That's fine, whatever. I just use is null or white space by habit. Now, the second thing that we got to do is string.join. In .NET 4, string.join was introduced in overload that took in an IEnumerable of string. The previous versions of string.join only took in arrays of strings, as you can see right here in the method signature. So to convert from an IEnumerable to an array, we can use the handy toArray extension method. And we can do the same with our pseudo classes. So that'll take care of those errors. And now I get a successful build for cgs.base. Now let's do cgs.compiler and cgs.compiler builds. Now let's do CGS engine. Okay, so all those nasty warnings went away. And like I said, the reason they went away is because I rebuilt these two projects, so it wasn't referencing a stale assembly. But now we have to do... Okay. First thing we got to do is let's fix this string.join. That's good. Let's build this guy again. And now we have an enum.tryparse. Yes, tryparse was introduced in .NET 4. Wonderful. It's introduced in .NET 3.5? Madness. Oh, right. It's a class to support it. Oh. Well, that works. Okay, I just got sent over a project for, apparently there is a replacement for tryparse that should work. Names, parse, tryparse. Ooh, it's generic too. This is kind of cool. Let's go ahead and grab it. Alright, I'm going to grab this enum class. I'm going to place it in my cgs.base. I'm just going to write a class called enum. Let's see here. Enum takes a T. It's static. Where T is struct. And then I'm going to grab you, import all the namespaces of everything, blah, blah, blah. Okay, so we get a build, and then I'm going to go ahead and toss in a documentation right there that points to from blah. Okay, so there we go. I just pulled down a little helper there, which should be nice. Looks like we're getting an error, yeah. Alright, so let's go ahead and do this. So instead of enum.tryparse, I'm going to do enum of colors.tryparse, passing in the identifier value, true for the ignore case, and an out for color enum. And that seems to have worked. So hooray for this guy. Anyway, whenever you pull down code like this, always credit the URL you grabbed it from. I don't know what license this is actually in. I don't know. I'll find that out later. Because right now I just got to make sure that my unit tests pass. And my unit tests pass. Okay, so now let's go ahead and introduce Unity. What I'm going to do is I'm going to create a cgs.unity project that's going to contain the Unity specific code. And the cgs.unity project is going to be what you pull down into Unity. So under Windows, Class Library, I'm going to create a cgs.unity. And I totally messed up because I forgot to change its target framework to 3.5 and remove that reference. Okay, so to test this, I'm going to have a couple static classes, or relatively singleton classes and then a static class that'll basically be the entry point into CGS. So what we need is our CGS environment, and what that's going to be is the CGS environment is going to basically be the entry point into CGS, if that makes sense. It's going to be the singleton that you work with to work with CGS as far as loading up style sheets. So let's go ahead and do this. I'm going to call this CGS ENVIROM or NMENT. Thank God for IntelliSense. I'm only going to have to type that once. And it's going to be a mono behavior. Of course, it can't be a mono behavior quite yet because we need to actually reference Unity. To do that, I'm going to open up my CGS Unity project in Explorer. I'm going to jump to the root of the project, go under lib. I'm going to add a new folder called Unity. Because we need to access the Unity engine to write all this code, I'm going to have to pull down a reference to the Unity engine assembly. And that's located under Program Files x86, Unity Editor, Data, Managed. There we go. Unity engine.dll. So I'm going to grab that, dump it right there. So now that I've done that, I'm going to go back up to my CGS Unity project, go to References, hit Add Reference, add a reference to, that's the wrong one, blah, 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 where am I going? There we go. Oh, it's just sorted weird. Lib, Unity engine, okay. That way, I can make CGS environment a mono behavior. So the whole idea of this being a mono behavior is that I can handle updates from the Unity subsystem to provide recompilation of my style sheets. What I mean by that is the style sheets that you work with during development will be recompiled every time you save out that file and then reloaded into the environment. I need it to be a mono behavior because I need to be able to hook into the main thread of Unity. So what I'm going to do is I'm going to create a private static CGS environment instance. And instance, instance, and then I'm going to have a public static CGS environment instance, which I'm not a super big fan of exposing a mono behavior through a singleton. That just seems nasty. What I want to go ahead and do is I want to jump into my CGS environment right here, take a look at it, because I already have a CGS environment class written, as you can see. Let's think. I actually think that I might have named this inappropriately. Or maybe I didn't. Did I? Maybe I didn't. Did I? No. Yes. Yeah. I don't like calling this a CGS environment. I would rather call this a CGS environment. So I'm going to rename this to the style sheet engine. Isn't that what I did before? Maybe. Way to get confused. I'll worry about that later. Doesn't matter. The most important thing is that I expose this behavior through an interface. That's basically all I'm trying to say. So I'm going to create an abstract iCGS environment. And that's what I'm going to expose to everybody through the singleton. And that's because I don't want people reaching into the internals of my environment and mucking around with things that they shouldn't. Okay, so the getter is basically going to say if instance equals null, then I'm going to create a game object. It's just going to be a new game object, CGS environment, which I guess I had to type twice or spell twice. Then I'm going to say instance equals game object dot add component CGS environment return instance. And of course, I actually have to have this mono behavior implement CGS environment. Okay, so really basic singleton. The first time you access it, it gets instantiated as a new game object, and then the CGS environment mono behavior gets attached to it. And then it gets returned as an interface that I can use to hide the implementation details of my CGS environment. So let's talk about the interface. All the interface really needs is going to be the ability to load a style sheet and to be able to retrieve a style for an element. So let's go ahead and do that. Say load style sheet, string name, or I need to be able to get a GUI style from an element. Not an IDN element, I don't even know what that means. I have to add a reference to CGS base to get that, and then I can go ahead and do that. Okay, so that's basically my public interface for CGS, pretty straightforward. Everything else is relatively hidden. And that just means I have to implement these two methods. My awesome load style sheet and get style sheet for element. So let's think. Let's think about this. So what I need to do is I need to implement the load style sheet. I'm going to implement the load style sheet right now, only for if we're in the editor. I'll worry about it later for loading it when we have a build. Because there's going to, like I said, there's two different situations. If we're in the editor, we want to attach a file watcher to our style sheet so that when we're developing, we can just save out our style sheet and have it reload instantly. Obviously, we don't want that behavior when we're in the thing. Also name, because it hides something. Let's go ahead and change this parameter name to style sheet name. I absolutely hate how Unity has properties that are lowercase. That is the most irritating thing about Unity, or one of the more irritating things about Unity. But whatever, can't do anything about that now. So I'm going to say if application.isEditor, then do something. Otherwise, I'm going to throw a new not implemented exception. We'll deal with the case where it's not an editor later. So what I need to do is the style sheet name is going to be using the resources, or the way that resources work with Unity. I hope all of you guys are familiar with that, where if you have a folder called resources anywhere in your assets folder, then it gets that file is then available to you through the resource.load method. So what I need to do though is I need to find the absolute path to a style sheet in order to attach a file watcher onto it. So I'm going to go ahead and say var path equals, and then I'm going to say find absolute resource path for style sheet name. And what that's going to do is that's going to return a string that represents the absolute path to a particular resource. Okay, so to do that, what I need to do is I need to, this is going to be fun. Yeah, I'm just going to brute force it. Whatever. I'm going to go ahead and say for each vardir in directory dot get directories. Then I'm going to pass in application dot data path, which when you're in the editor will point to your assets folder. Then I'm going to say find any folder called resources and search all directories for it. So what I'm saying is loop through every single directory called resources in my asset path, and then I'm going to do something kind of meh, but it works. I'm going to say, hold on, someone's posting things. Streaming assets path contains the path to the streaming assets folder. If you have a streaming assets folder in the assets folder, it'll be copied to your player builds and present by streaming assets. I mean, is there a reason to use streaming assets over normal resources for loading style sheets? My understanding is that loading resources is going to be more appropriate for this sort of thing, because I'm not wanting to stream in a style sheet. Unity doesn't copy unrecognized file paths. Blah, blah. I'll put unrecognized file types into the build. Is that like a new addition? Because I'm pretty like, seems like something silly to overlook. Not text, HTML, or XML. Most assets using are combined in the project and built. However, sometimes it's useful to place the files into the normal file system on the target machine to make them accessible. An example is this deployment of a movie. Any files placed in a folder called streaming assets in the Unity project will be copied verbatim to a particular folder on the target machine. On a desktop computer, location can be obtained with application.datapath plus streaming assets. You don't happen to be Justin, do you? Because I don't know that guy's username. Huh. And so what you ended up doing was using streaming assets, or using a different did you ever end up committing that change to the thingy? Alright. Okay. Well, in that case, let's go ahead and use streaming assets then. Although, let me do a quick Google search for something. Unity... Text assets file, when you drop a text, it will be converted into a text. See, what's weird is that I wonder what I did when I created the build when I was actually writing CGS. Because I did test that code. It's written. Yeah, I never did anything with Unity 3 or Unity 4 when I built it, because I put it together a year ago. Huh. Alright. Well, in that case, I guess we're going to be using streaming assets. So let's figure out how to use streaming assets. According to the documentation, it says that it is expecting files underneath a streaming assets folder, which makes the find absolute resource path function a lot easier. I'm going to go ahead and change the name of this to find absolute streaming asset path. And what I'm going to do is I'm going to say var expected path equals path dot combine application dot streaming assets path style sheet name. If not file exists expected path, throw new invalid operation exception. Or how about there should be a file not found exception somewhere. There you are. Blah does not exist. Okay, so there's our awesome code for doing that stuff. All right. Okay, so now that I have my path, I can now go ahead and create a new style sheet watcher, and I can go ahead and cache the existence of this style sheet being added or being on the environment. Because if, for example, two different mono behaviors both include the same style sheet, I only want to actually include it once in my project. So to do that, I'm going to create a... actually, didn't I use a hash set somewhere in my project and then it didn't fail to compile? Yeah, I did. Huh. Where are you coming from? Could have sworn that hash set came from .NET 4. Blah, blah, blah. I guess not. Okay, so that means I can go ahead and use a hash set for my CGS environment. I'm going to create a private read-only hash set string loaded style sheets public void awake loaded style sheets. Just instantiate that. Can't be read-only, obviously, because that's not a constructor. Mono behaviors sometimes really irritate me. Then I'm going to go ahead and say if, for my hash set, I do want to create it with a string compare of current culture ignore case. And then I'm going to say if loaded style sheets contains path, then return. Otherwise, add it to it. So add it to path. Actually, there's a slight optimization I can do. Instead of doing this, I could simply have done if loaded style sheets dot add path. That'll return true if it was successfully added to the hash set. So then what I need to do is I need to instantiate some sort of class that'll be responsible for watching my style sheets. So I'm going to create a class called Unity Style Sheet Watcher, and its constructor is going to take in a string path. That will be where it points to. Then my CGS environment, or this CGS environment, is going to have a private list of Unity Style Sheet Watchers called Style Sheet Watchers. And what they're going to do is when I add a style sheet and I'm in the editor, I'm going to say style sheet watchers.add new Unity Style Sheet Watcher path. Okay, so that should hopefully make sense to people, I suppose. So let's go ahead and jump back into Unity Style Sheet Watcher. Now, what I want to do with CGS is I want the Style Sheet Watchers to recompile the style sheets on the main Unity thread. The reason I want that is I don't want the style sheets to be recompiled while an on GUI is happening. I don't want to recompile the style sheets as someone else is accessing the CGS environment. So to do that, I'm going to go back to my CGS environment, and I'm going to create an update method. And what the update method is going to do is he's just going to loop through all his watchers and say watchers.update. So that way the watchers are now tied into the main Unity thread, which is important because I'm going to be taking advantage of the basic, the file system watcher, which will be publishing its events on a separate thread. So because I'm going to be using a file watcher, I'm going to jump back into my my ANTLR watcher. and remind myself how this code is even supposed to look. Because we did use this class in this project. After it loads, of course, which takes forever. Okay, we instantiate, pass in a directory or a file, I imagine, right? Yeah, file. Blah, blah, blah. And... okay, it's pretty straightforward. So I'm going to create a private read-only file system watcher called watcher, and then I'm going to instantiate it here, passing in the path of the file. Then I need to, what do I need to do after I do that? I need to tell it watcher.changed. I'll create a new method, watcher.onChanged. Then I'll say watcher.enable raising events equals true. Okay, so then watcher.onChange, all that's going to do is it's going to basically tell my file watcher that I need to be updated. And then the actual recompilation is going to happen within that update method. So let's think. Watcher, sorry, I'm just going through the code really quickly. Okay, so on watcher.onChange, to make sure I don't get two changes happening at once, I need to disable raising events. Then at the end of this method, I need to enable raising events. Otherwise, I might get multiple watcher.onChange invocations. Plus equals watcher.onChanged. That's, yeah, that's just a basic event. And it looks like I just lost my internet connection. So to all you future people, I will be right back. Okay, we're back. So now that I have my watcher being invoked on a separate thread, what I need to do is I am going to add a private volatile bool should recompile, and I'm going to set it to true if that happens. Then on my update, I'm going to say if should recompile, then invoke a compile method. The compile method is also going to be invoked when the class is instantiated. Okay. Am I still here? Okay, and we're back again. Sorry about that, guys. We're having some connectivity issues. Alright, so now we have the compile method, which should get invoked on the instantiation of a Unity style sheet watcher. And it should also get invoked on the main Unity thread if the watcher detected a change. So what's the compile method going to do? Well, the compile method it's going to compile the style sheet. Okay, so what I need is I need a private iStyleSheet style sheet. And the reason I need this is I need to keep track of the style sheet that was previously compiled. That's because I need to be able to unregister the old style sheet, recompile the new one, and then re-register the new one. So what I'm going to do is I'm going to say if our current style sheet does not equal null, then we have to unregister the current style sheet. Now that means we need access to our CGS environment, which is right here. We need our CGS environment so that we can register a style sheet and we can unregister a style sheet. So we have build style sheet and remove style sheet. So what I'm going to do is I'm going to rename this finally CGS Engine. Now it doesn't really need an interface because everything that CGS Engine can do publicly I'm fine with passing around, so I'm going to leave it as a concrete class. Then I'm going to jump back into my Unity Style Sheet Watcher, change my constructor to get a reference of the engine in, which I have to add a reference to cgs.engine. And now that I've done that, I can go back down to the compile method, which remember is invoked when we instantiate our thing and when the thing changes. I'm going to say underscore engine dot remove style sheet. Then what I need to do is I need to, well, compile the style sheet. So I'm going to say engine dot build style sheet builder, and then I'm going to say style sheet compiler, which is going to require that I pull in cgs.compiler, .compile file builder path. So that's really all there is to it. The last thing that I got to do is I do actually have to handle logging. The reason I have to handle logging is I want anything logged from a builder to go into the Unity's debug console. So to do that, I guess I'm going to go ahead and create a static class called CGS log, public static class CGS log, and then I'm going to say item logged plus equals CGS log dot log item. I'll create that method. Then what I'm going to do is I'm going to say, how about a switch on item dot level. Okay, so I have to do my info, warning, error, and parser. So my info is going to be debug dot log. Wrong debug. I want Unity Engine's debug. Debug dot lob log. Then we have to do a message. I'm going to pass in just item, because remember, item has a toString implementation, which, well, does everything it needs to. Okay, so if we get a warning, I'm going to say debug.log warning item.toString. If we get an error, I'm going to say debug.log error item.toString. And if we get a parse error, I'm also going to say log error. So there's a really basic shim that I'll use between our debug logs and our style sheet log. Okay, the last thing I need to do is I actually need to set my existing style sheet reference to the result of building out a style sheet using the engine. So that's pretty straightforward. Okay, so now if I jump back into my CGS environment, we have loaded style sheet watchers, they get updated, they get added. Now I need to pass in a reference to CGS engine. I'm going to have that be a private CGS engine, which is simply responsible again for loading style sheets up into it. Okay, so now that we have that done, let's think. Let's see about getting this into Unity first, now that we have that done. I'm going to do a build, and it says build succeeded. That's cool. I'm going to fire up Unity. I'm going to say open other. I'm going to navigate to MMO Dev class, Cascading GUI Sheets. I'm going to create a new folder within this called Unity, and that's where I'm going to basically have a test project that represents a thing. Why can't I select the folder? Oh, I said open, I didn't say create. Create, browse, blah, 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 MMO dev class, Cascading GUI Sheets, Unity, select folder, and create. Okay, so the first thing that I need to do in order to test this is, well, I need to save out a scene first. And I'm just going to call this scene 1. Then I also need a, I'm just going to write a code folder, and I'm going to dump in a new mono behavior, and I'm going to call it something, test screen or something, to test CGS. Then I'm going to create a streaming assets folder. Underneath streaming assets, I am going to create, I'm actually going to say show in Explorer. I'm going to go in streaming assets, and I'm going to create a text document, and I'm going to call it stylesheet.cgs. And then I'm going to open you up in Sublime Text, and I'm going to set your syntax highlighting, if I can remember how to do that. Why do I always forget the simplest? There we go. I'm going to set the syntax highlighting to less, because CGS is very similar to less. Okay, so now that I have all that done, I can go ahead and sync my MonoDevelop project and then open this up in Visual Studio, which for some reason directly launching Visual Studio from Unity isn't working on my computer. So I have to go in and manually open up Unity C#. Or maybe it just did. Did it? No, it didn't. Of course it didn't. Why would it? Things working. Okay, and then the last thing I gotta do, now that I have all of this sort of monotony out of the way, is I have to compile my assemblies into Unity, which is very easy to do. I'm going to create a new folder called Assemblies. Okay, so I have a new folder called Assemblies. I'm going to jump back into my Cascading GUI Sheets project, right-click on Unity, go to Properties, go to Build, and set the output path to Cascading GUI Sheets, Unity, Assets, Assemblies. Select folder, save, Control-Shift-B, jump back into Unity. We can see that our assemblies have been pulled down, including our CGS Unity one that has a mono behavior inside of it, which is nice. But we never need to manually create one because it's always created from the singleton. Wait a second. Assembly. Oh, derp. Yeah, I don't want to use the Unity. I don't want the Unity engine to have copy local to equal true, because if Unity engine has copy local equals true, then it'll copy it into the assemblies folder, which will confuse Unity. So all you gotta do is go to the reference, go to properties, and set copy local to false. So now if I build, that works. Now I can jump back into my Unity C#, hit reload, and I now have a test screen mono behavior. So first thing I'm going to do is adjust my namespaces. Then I'm going to delete all that garbage. And I'm going to create a public void awake. And all awake is going to do is CGS environment dot instance dot load style sheet, and I'm going to be loading something. What did I call you? stylesheet.cgs. Okay, so let's put something in stylesheet.cgs. I'm going to go ahead and say thing has a color of blue. Should be simple enough. Jump back into Unity and add test screen, attach it to my main camera, and hit run and see what happens. We get a null reference exception. ANTLR compile file. Let's see here. It says the encoding is null. That's coming from a stream reader? Madness. Which is being invoked by stream reader, blah blah blah, which is being invoked by read all text, which is being invoked by ANTLR filestream.load. Weird. Let's just pass it into encoding. Let's just assume everything is UTF-8. Why not? It's gross. I wonder if there's a get encoding. Wait a second, of course there won't be. That's dumb. Why did I even suggest that? Let's just assume everything's in UTF-8. I mean, that'll work if they're in ASCII as well, so it doesn't matter. And it'll also, if there's a bomb, it'll ignore it. Still can't be null. Probably because I forgot to recompile. That's the one annoying thing about having multiple projects, is you have to be sure to recompile them, jump back into Unity, and then hit play, and we get directory does not exists. Seriously? Where are you coming from? File system watcher seriously has directory does not exists. Hold on, let me make sure this isn't my code first, because that's just embarrassing. Nope. Wonderful. I have a lot of faith in this implementation of file system watcher. Okay, so it's saying something about directory does not exist. I think what I'm doing is I'm not using the directory or the file system watcher correctly. Yeah, I think what I need to do is I'm pretty sure you can only use this to watch directories, actually, now that I think about it. Stack Overflow to the rescue. Okay, so it only does work with directories, but we can simulate that by doing path.getDirectoryName path, and then I can set the filter of the watcher to path.getFileName of path. And hey, look, no errors. So let's see if we are actually working. So if I go ahead and remove a semicolon and save, nothing happens. That could be because I don't have run in background set. Build settings, player settings, blah blah blah. Where are you? Run in background. Hey, check that out. Oh. Yeah, that's not good. It looks like I forgot to reset the should recompile. If we compile, if we do update, I'm going to swap that false. Although, let's see here. Something isn't right. If we build the style sheet builder equals new, what happens when you, okay, just don't do anything. That's fine. So if there's an error, we still get a style sheet returned back to us. It just doesn't have any rules inside of it. Okay, so now we get one error. I'm going to remove collapse, and let's look at how these errors are presented to us. Streaming asset style sheet CGS 3.0. Parse error, no viable alternative at input. That's really cool. I do want to do one thing though. When I do my logging, okay, var message equals location. Okay, I'm just going to go ahead and copy and paste this. The reason I'm doing this is I don't want to display the entire full path in my errors. You'll see what I mean in a second. Instead, I just wanted to post. I want to post them relative to where Unity is. So location is going to be item.location. Get name is going to be item.level. Message can be item.message. Now for the location. Wonderful. Shut up. File line character position. So we have file line character position 3 and then 4. So location dot file item location line item location character position. But the file, what I want to do is I want to say if the file dot length is greater than application dot streaming assets path, then return item dot location dot file dot substring of application dot streaming assets path dot length. Otherwise, just return item location file. And then to make this code a little bit more readable, I'll dump it like that. And we're getting an error because it's streaming assets dot length. Okay, so that'll just chop off the message or chop off the path to our Unity project from our logging. So that's pretty straightforward. So now I get, well, maybe it's not so straightforward. Of course, I forgot to rebuild. I'm going to do that a lot. Haven't you guys? There we go. It looks like the last thing I need to do is get rid of that nasty slash, and then we should be good to go. And by doing that, I'm going to do +1 here and +1 right here. And I'm going to recompile. Okay, now we're getting our parsers, and I can change up the parsers a little bit. So by doing that, it'll reload. I can go ahead and add in another parser right there. It gives me a sharing violation. What? Madness. Sharing violation. Why are you getting a sharing violation? I don't know why. Seems to only happen some of the time. Okay, let's see if my property errors show up. So if I set color to, well, that would work. If I set color to 50 pixels, then what I get, look at that. It says stylesheet.cgs, line number 2, character 1, error, expected color or named color. And if I do background is 50%, I'll get value of type number value is invalid. Well, whatever. At least it shows me the line number that the error happens. But if I did things correctly, like whoa, hey, h2 stuff, and things, then we don't get any errors. Okay, so that means that CGS is properly violating its sharing for some reason. I don't know why. I don't know what this is. Whatever, I'll figure it out later. But we do have a CGS environment loading style sheets up into the project, and they also watch the style sheets as you modify them. So that's really cool. The next step is going to be to translate a computed style into a GUI style, and that's where things are going to get annoying. Alright, so I'm going to go ahead and go on break for a couple minutes, and I'll see you guys in a moment. Alrighty, and we're back. So, yeah, code. At this point, we have to start thinking about how we're going to translate our properties, of which we have quite a few, into GUI skins. So this is really going to be the second to last step that we have to go through. And the reason I say second to last step is before we figure that out, we also have to figure out how exactly we're going to express our markup, quote unquote. Now the way that I'm going to do it in this particular case is I'm not going to use a markup language like HTML or anything like that or anything custom. Instead, I'm just going to be using straight up C# with delegates. And I'm going to do that because, well, we're working against Unity's GUI system and it'll be easier to do it this way. In fact, the code that I'm about to write is actually how CGS started. CGS really started as me wanting to have a cleaner syntax for defining GUI skins. Then it graduated into me wanting to actually style the GUI skins themselves. So let's talk about that. What we need is we need a way to build out a GUI. So I'm going to create a iCGS GUI builder interface. What that's going to be responsible for is, well, creating a GUI. So iCGS GUI builder, which is an awful wow. It just looks like a bunch of... It's just like someone threw up on the keyboard. But that's okay. Okay, so what I'm going to need to do is I need a way to express elements, just like you would do in HTML. So what I'm going to do is I'm going to have stuff like a div, and an h1, and an h2, and a scroll. And the way these methods are going to work is that they're going to take in a delegate that allows you to create nested elements. So that's how we're going to express our hierarchy. So let's start off with some easy ones. Well, let's just go ahead and implement these four first. Div is going to take in a couple different overloads. The first overload is going to take in just an action called action. Now, it's going to have a couple other overloads, and the reason it needs a couple other overloads is I need to be able to change the attributes of an element. For example, I need to be able to add a class or an ID or stuff like that to my elements. The way that I'm going to... apparently I'm running a new version of Push now. Yay! The way that I'm going to express this is very similar to how the GUI layout actually works. I got the inspiration of writing it this way from GUI layout actually. And what I need is a concept of an iElement property, which I'm going to change the name to iElement attribute because that's a little bit more appropriate. Now, an iElement attribute is going to be able to be passed in to our overloads of my different things. So we'll have like one that takes in one attribute, one that takes in two attributes, and then one that takes in a variable amount of attributes. No, I always want them to be in the front, so I'm going to do an iEnumerable of iElement attribute, attributes, action, action. So where do we get iElement attributes from? Well, we get them from methods that are on this actual interface. I need an iElement attribute method for getting an ID. For example, I need an iElement attribute for getting a class, which unfortunately I can't call class because that's a keyword, so I'm going to abbreviate CLS. And then I need a type to overload the type of an element. One's going to take in a string, and one's going to take in an element type. Okay, so now I need to go ahead and create the overloads for my H1s and H2s and all that fun stuff. Well, I'm not going to, in CGS, I'm not going to support any nesting within like an H1, for example. You're going to handle that through divs, and that's just to make the language a little bit more straightforward. So an H1 is going to take in text, and it's going to take in a params iElement attributes. So that's all an H1 is going to take in. Same with an H2, and that's going to be the implementation of that. The next up, I'm going to go ahead and implement scroll for scroll bars, and I'm going to take in a ref vector2 of position, and then an action. So this interface is actually going to get a lot larger as we add more elements, but this is a good starting point. I'm going to go ahead and I'm going to say suppress inspection inconsistent naming with comment. And I'm doing that because I am having inconsistent naming right here. These names don't actually follow the C# standard. They don't because I explicitly want them to be lowercase to be a little bit more similar to HTML. Okay, so that's the basic CGS GUI builder. What I'm going to do next is I need an entry point to that. I need a way to start using a builder to construct a user interface. So I'm going to create a CGS GUI. All he's going to have is a public static void build method that takes in an action of type iCGS GUI builder, and it's going to be called action. And then it's going to invoke action with a new instantiation of a class that implements iCGS GUI builder, which not surprisingly is going to be called CGS GUI builder. And that's it. That's my public interface for CGS. That's pretty much all my public interface for CGS if we had all of these different methods implemented. What do I mean by that? Well, if I go ahead and build this out, the way that CGS looks when we actually define our interfaces is something similar to HTML. See, I'm going to go ahead and say public void on GUI, and I'm going to say CGS GUI dot build G, and then G dot div, G dot ID, how about page wrap, and then say G dot H1, this is a header 1, G dot H2, this is a header 2, then G dot div, G dot ID of, or how about G dot class of test, and then G dot scroll, pass in a ref, so we'll have a private vector2 scroll position, and we'll pass then this in as a ref scroll position, and then inside the action I'll go ahead and just say for var I equals 0, I smaller 100, I plus plus, G dot H1. So that's CGS right there. That's basically all the public interface that we need. We have our loading of our style sheet, and then we have our actual GUI being built out. So it's already looking a whole lot cleaner than if we were trying to express complex layouts using GUI layout. And that's actually exactly what we're about to do, because that's all CGS GUI Builder does, is it wraps around a GUI layout invocations. So let's do our iElement attributes first. iElement attributes, all they do is they modify an element, and the implementation of element that I have, let's see here. I'm going to have to make this mutable. So let's see how this will work. So for my iElement attributes, what I'm going to need is new attributes. I'm going to need an ID attribute. Every single element attribute will have a apply method that takes in an element. And then for my ID attribute, we'll simply apply an ID that you passed into the constructor. So I'll say element.id equals ID. Now, at the moment, I do not have a public setter on my ID property for my element. So I'm going to have to do that. But that introduces an issue. And the issue is that my unique ID is generated, and every time that I modify my ID or my type or my classes or my pseudo classes, I have to regenerate my unique ID. So let's go ahead and do that. For my ID, I'm just going to basically turn this into a property with a backing field, and then after I set it, I'm going to say generate unique ID. Pretty straightforward. For my type, I'm going to turn it into a property with a backing field, and after I set it, I'm going to say generate unique ID. For my classes and pseudo classes, I'm going to add two methods for each one: add class, remove class, add pseudo class, remove pseudo class, and each one of those methods will regenerate the unique ID for that given element. So I'm going to create a public void add class, string class, classes.add class, generate unique ID. Then I need a remove class method. Since remove returns a bool, I'll say if you did remove it, then generate unique ID. Then I need my pseudos. So add pseudo class, remove pseudo class, and that will just do pseudo classes and pseudo classes. Actually, what I am going to do is classes and pseudo classes you should only ever have one of on a particular element. So I'm going to change my I'm going to change from a list to a hash set, which won't affect most of my code, but the difference is that I can now say if we did add a new class, then regenerate the unique ID. If we did add a pseudo class, then regenerate the unique ID. So I still build, I think, I do still build. My tests should still pass. Okay. So now that I have my element done like that, I can now set my IDs and add classes. So my ID attribute will simply set the ID. My type attribute will set the type. Element.type equals element, which on my type I forgot to set the setter to a private setter. And of course I get text for some reason, because I forgot to turn off my phone. So we have our type attribute, our ID attribute, we need a class attribute. Class attribute will take in a string class name. and it'll simply add a class, and I think that's all we need. Okay, so jumping back into our CGS GUI builder, when we get a new ID attribute, I'm simply going to return a new ID attribute, pass an ID. When we get a new class attribute, I'll return that. When we get a new type attribute, I will do that. And when we get a new type attribute, I will do that. Okay, so those are our basic attributes for our elements. So now we can override the ID, the class, and the type of our element. So that's cool. So now what we need to do is we need to make this syntax work. What do I mean by that? Well, every time one of these methods gets invoked, like h1, h2, and so on, it needs to generate a new element. And then that element will be used to determine the style for the element, and then that style will be used to set a GUI skin. After we set the GUI skin, we will invoke the GUI layout's corresponding member. So what we need is we need a stack of elements. So I'm going to create a private read-only stack of I element, or just elements, really. I'm just working with the base type right now. And then every time we get a div or an h1 or an h2 or a scroll, we need to create a new element and then set the new element's parent to whoever's on the top of the stack. So I'm going to create a little helper method. I'm going to create a private element, create element, passing in an IEnumerable of I element attributes called attributes. And I think that is all I'm going to be needing for actually creating an element. Although, just to make things a little bit simpler, I will also pass in an element type. So to create an element, all I got to do is I got to say var element equals new element with the corresponding element type, and then a parent of, now this is where things get important, I need to give it a parent of whoever is at the top of my stack. So I need to say if elements.any, then return elements.peak, otherwise null, because it has no parent. Then I have to loop through all the attributes and apply them to my element. Then I have to push my element onto the stack, and then I'll return my element. So that means that this div will be implemented. Well, I'm actually going to implement this div and this div and this div all in terms of the final div. So to do that, I'm going to say div enumerable.empty I element attribute action. This is going to be div.newArray of attribute, passing in action. This is going to be a div with a new array of attribute 1 and attribute 2, passing in action. And then finally, I can implement my div method. So my div method is first going to create a new element. So var element equals create element, passing in an element of type of div with my attributes. Then I'm going to invoke my action, and then I'm going to pop the element off the stack. Now, before I invoke the action, I actually have to go out, or for a div, what I need to do is I need to either start a horizontal layout group or a vertical layout group, depending on if our what our flow property is set as. The reason I don't want to use params is because I want the delegate to appear before the properties. So I want me to be able to do g.id page wrap, comma, and then the delegate, instead of having the attributes being set at the end after the delegate, I think that will just look a lot uglier. Okay, so we create the element, and then we got to begin a vertical or begin a horizontal. And that's going to require that I get the current computed style for this element. So var style equals, and I have to get the current computed style, which I believe will be CGS environment, CGS environment dot instance dot get style for element passing an element. Then I'll do var flow equals style dot, wait a sec, that's not going to return a computed style, that's actually going to return a GUI style. Which this is where things, like I said before, I was warning everyone, are going to get very, very tricky for determining our stuff. I'm going to try something. I'm going to go ahead and create a class called CGS style that takes in an will take in an element, I don't know, but it'll definitely take in an iComputed style. And then it'll also have the ability to return a GUI style. But it'll expose our style why do I even implement that method? I don't even know. I'm going to go ahead and encapsulate this as an automatic property, and then my iCGS environment is going to return a CGS style, which will allow me to, this class will be responsible for wrapping a GUI style and a computed style. So that way I can say var flow equals CGS environment instance get style for element, which I'll alias out into a variable. And then flow is going to be style.get property flow property dot value. And then if flow is equal to horizontal, then GUI layout dot begin horizontal. Otherwise, GUI layout dot begin vertical. And then we'll do the same thing here. If flow equals flow dot horizontal, then GUI layout dot end horizontal. Otherwise, GUI layout dot end vertical. Alright, so there's our div. For our H1s and our H2s, they will be pretty straightforward. We're going to do this exact same thing. We're going to get the element, and then we're going to get the style, and then I'm simply going to say GUI layout dot label, and I'm going to pass in the text. Now, you do notice that right now, at this particular moment, I'm ignoring all my CGS styles at the moment, but we'll fix that later. So I'll do GUI layout dot label text. Now for scroll, my scroll is going to be basically the same thing, except for we're going to have a special element type in this case, because there really isn't a corresponding HTML element that really makes sense in the case of a scroll view. So there's a variety of different ways we can do this. I can go ahead and I'm going to just go ahead and call it scroll. We're not tied to HTML. So I'll create an element called scroll. As far as my attributes, I do need to actually pass in attributes into my scroll, which I forgot to mention before. So let me go ahead and implement those on my interface, iCGS GUI Builder. I'll have a scroll, let's see, okay, so I'll have one like that. I'll have one like this. And then I'll have one like this, and then I'll have one like that. Whoops. Okay, so there's our scroll. Let me go ahead and have ReSharper generate those method stubs for me. Alright, so my scroll is actually going to, all of these scroll methods are going to be implemented in terms of the bottom one right here. So to do that, let me go ahead and reorder everything so that the interfaces and the concrete classes match up. This scroll is simply going to do scroll enumerable.empty I element attribute, passing in ref position and action. This scroll is going to be scroll new array of attribute 1, passing in ref position and action. This scroll is going to be new array of attribute 1 and attribute 2, passing in ref position and our action. And then the final one will calculate the style. It'll say GUI layout.begin scroll view. It'll pass in position and then nothing else for now. It'll simply say position equals that. I'll say action, invoke the action, and then GUI layout.end scroll view, like that. Okay, I do have a slight problem with my create element. At the moment, my create element does push onto the elements array, but not all of my different things actually need it. So you know what I'm going to do? I'm going to introduce a nice little, I'm going to introduce an action of element action, make this return void. I'm going to invoke action with element after I push it on, and then I'll pop it like that. Okay, so create element is going to now look like this. That way, we do not have to worry about if an element needs to be popped or not. Position doesn't work. Oh, you can't use ref or out inside of anonymous method body? Well, that's stupid. That even work? Maybe. I don't think so. No, it should. Yeah, maybe. No idea. I've never tried to use a ref or out parameter within a anonymous method body. Seems like kind of a bizarre thing to do. But, hey, look, I cleaned up our code a little bit, and that's the most important thing. So now if I go over to my div, all I gotta do to refactor this is do that, and then remove the element.pop. Then for my h1, to refactor this, I will do that. And my h2 is going to be basically the exact same code, except for it's going to be an h2. Okay, so now I have my h1, h2, div, and scroll implemented, but currently it doesn't take anything from CGS yet. But that's not exactly what we're trying to do at this very second. What don't you implement? Oh, it doesn't. CGS style, return new CGS style from engine dot build style for element. Okay, so that's cool, I guess. Alright, so let's see. Right now, the only thing that I'm implementing in CGS that'll actually change the behavior of something is my flow property. So what I'm going to do is I'm going to jump into my engine property types, flow, go ahead and copy vertical. And then I'm going to... Okay, so we have an ID of page wrap. That means I should be able to say pound page wrap flow vertical. And that should make everything flow vertically. Or not. Huh? No viable alternative, a character W. Oh, please don't tell me that I didn't support stupid dashes and class names and IDs. I don't think I did. Well, that's wonderful. We'll deal with that next week. For this, I just want to see something work. So we have our flow vertical. Now if we do flow horizontal and save, we get horizontal flowing. So if we do vertical flowing, we get vertical flowing. If we do horizontal flowing, we get horizontal flowing. So that's the first property of CGS that is being implemented. So that's pretty cool to see. Okay, so at this point we have quite a bit there in place. We basically have the entire language built. We have the entire API to that language built. All we're missing at this point is our mapping between our properties and our GUI styles. So I think that's pretty much, unfortunately, there's a whole lot of other stuff that we're going to have to do when working with that, but that really is the last thing that we have to implement. So I think that I guess that about wraps everything up for this week. The next time we meet, we'll be taking a look at our CGS style class, and we'll use the CGS style in order to, we'll use it to construct a GUI skin, and we'll also use it for layout and positioning and all that fun stuff. And then we'll also get more elements implemented. Well, I guess before we leave, I can go ahead and implement a couple other elements. Why not? H1, H2, let's do all of the standard HTML H's. 3, 4, 5, 6. 3, 4, 5, 6. I do not know how to count. Okay, so we have our headers. Let's do a span, an EM, a strong, a P, a label. And I think that should be good. So we have our span, EM, strong, P, and label. And then H6 because I accidentally deleted that. Okay, so let's go ahead and implement those in our CGS builder. Basically, these can all be implemented in terms of a single method that I'm going to go ahead and write down at the bottom. I'm going to say private void label. Private void label will basically take in the exact same signature, but it'll also take in a string type. And all label is going to do is basically what our existing ones do already, except for I'm going to overload the type. And now we can write all of these different things in terms of that by doing label, text attributes, H1, text attributes, and then we need our H2, H3, H4, H5, H6, span, EM, strong, P, and label. Alrighty. So that pretty much wraps everything up for this week, I guess. Quite a few different things that we can use. So yeah, how's everyone feeling? We're going to be meeting again on the 16th of July. So yeah, I guess to all you future people, I will talk to you later.